All right, friends and neighbors, welcome back to our CCNA journey. This time out, we are looking at Chapter 7, Configuring and Verifying Switch Interfaces. So we're going to be doing a lot of manipulation there, and we'll have a little bit of fun with that. So here we go. In this video, we will do the Do You Know This Already questions. There's a lot of them for this chapter. We'll talk about interface speed and duplex. These are some important issues to take a look at. It's also really nice to know about auto negotiation and auto-MDIX. And then we'll do a bunch of stuff with the switch interfaces and the status and some statistics. We will visit the no command, and then we'll talk a little bit about troubleshooting. All right, do you know this already? So this is a busy slide. And a lot of these questions, right, if you knew the answers to these questions, there's no reason to do the chapter. But of course, it's nice to hear these things a couple of times. So I'm going to do all of the questions like I always do, and then we'll talk about most of these things in the chapter. So a switch port and a PC are connected, and both are configured for IEEE auto negotiation. Which answer best describes how the switch chooses or will choose its speed and duplex? So we have to know a couple of things about that, but when you're auto negotiation, I'll show you an example of what the pulses look like, but it's just messages that are going back and forth between the devices. And so both the speed and the duplex will be configured by comparing auto negotiation messages. In which of the following modes of the CLI could you configure the duplex setting for int f0/5? Well, to do this, there's only really one answer. You have all of this stuff, almost all of this stuff, occurs in the interface configuration mode. A switch and a PC are connected. The switch port is configured for IEEE auto negotiation, but the PC is not. Which answer best describes how the switch choose its speed and duplex settings? Well, you have to know a little bit about how this is done. The speed will be determined by the signal. So what ends up happening is that one side that wants to auto negotiate now has to look at the speed at which things are coming and go, yeah, I think that's 100 megabits per second. And whatever speed is chosen, that'll determine the duplex nature of the port. Switch interface gig 101/0/5 has been cabled correctly, but the engineer wants to prevent the interface from being used until the engineer enables it remotely. This was for the weekend work that was going to be done. Which action helps achieve that goal? Well, one of them was disconnect the cable, but if you're remote, then you can't reconnect the cable. So the answer here is that you have to go in and shut down the interface. Then when you remote in, assuming you're not remoting in via that port, you would do a no shut on the interface. An engineer configures a switch with the interface range command and then a description connected to the endpoint device. So that's actually a command. Description connected to an endpoint device. The engineer exits and issues a show running config command. Which answers best describe the related output? Choose two. Well, the interface range command is not part of the output, so that was one of them. And then the other thing is that when you do an interface range command, it goes for a whole bunch of ports, and then if you do a description, it'll be applied to all of those. So that was the answer there. The output from show interface status shows f0/1 in the disabled state. Which of the following is true about int f0/1? Choose three answers. Well, if it's disabled, then it's shut down. So that's what happens. We'll see what that looks like. The interface in the protocol will be down, and then you cannot use that port to forward frames. So switch 1 and 2 are connected via 10, 100, 1000 ports. Switch 2 configuration the switch 2 configuration includes speed and duplex commands, which disables the auto negotiation for that port. Which combinations result in a duplex mismatch between switch 1 and switch 2? Choose 2. Well, we have to know a couple things here. One is that the speed will determine the duplex nature. And in both cases, a duplex mismatch with an auto configuration port will happen when you have the speed of 10 or 100 and a full duplex, because both of those would result in half duplex. Switch 1 connects via cable to switch 2's gig 1/0/1 port. Which of the following conditions is the most likely to cause switch 1's late collision counter to increment? Well, a good thing to remember is that you don't have collisions in non-shared media or in full duplex. So if you have something with a half duplex ending and the other side is trying to auto negotiate or anything like that, that'll result in the collisions. So it's the duplex mismatch with switch 1 set to half duplex. If you didn't understand what in the world I was talking about, we're going to cover all these things over the course of the video. So configuring switch interface speed and duplex. Now the evidence that negotiation is a thing is that, right, you buy a NIC today or you look at the options that are available with a port, you can see that they're 10, 100, 1000, or 10, 100. That indicates that you could do any of those speeds. But it turns out that we auto-negotiate. The two sides figure out the way that it's going to work. Now, the goal for IEEE auto-negotiation is to find the fastest speed possible, but also to configure the duplex nature of the connection. Now, if you couldn't remember what duplex means, duplex refers to how the two sides are communicating. So if you're in a conversation, right? You and I are talking, and I talk, then you talk, that's half duplex, meaning that we're not talking at the same time. We see half duplex mode used in a lot of shared media. So traditional Ethernet with hubs, that was half duplex. Wireless today is half duplex. This is why we have collisions. If two nodes try to talk at the same time, then their transmissions can collide with each other on the bus or in the air in the case of wireless. And this is why we have access methods. So carrier sense multiple access with collision detection or collision avoidance in the case of wireless. That's what that's all about. We're negotiating communication on a shared or half duplex medium. Full duplex is what switches want to do, right? If you've got a node connected to a switch or two switches connected together, they're going to do full duplex, which means that the two sides can talk at the same time. It effectively doubles the bandwidth on that link. Now, one of the other things to remember here is that when we're talking about speeds and we're talking about duplex, it's very nice to be able to go 1 gigabits per second, right, or 1,000 megabits per second, and full duplex. But make sure that your cabling is a match for that, right? If you are looking at your patch cables and you're putting in Cat5, or maybe even Cat5e, or your plenum cable is those Cat5 or Cat5e, or God help us, Cat3, then you're not going to be able to get up to a gig on a regular basis or on a reliable basis. And that might also cause problems for full duplex communication. So how does auto negotiation work? Well, we can see a couple of sections about this in the IEEE 802.3 2012 version. That's one of the latest and greatest from the Ethernet standards body. And I've got a picture above me here of what the pulses look like. So what we're talking about here is something called the fast link pulse. And so if you imagine the two sides, you plug in a cable and they immediately start firing these pulses back and forth. And the whole idea is to advertise your capability, and then the two sides figure out what they want to do. Now, this looks like just pulses, but what we're also doing is measuring the time distance between the pulses, the time of the pulses, and so there's a lot going on here. This is just an example so you have a visual to go along with the idea of the pulses. So we've got this idea of a local device and its link partner, and then you power up and you start sending these link pulses. There are 33 pulse positions in all, and then there's a whole bunch of messages that you can communicate with those pulses. Now, there's not supposed to be any pulses after auto negotiation is complete, because then we want to get into Ethernet data transmission, right? So that's why we call this sort of out-of-band transmission. But also there is the ability to renegotiate capabilities after changes to a link are made. Now, traditionally, Ethernet had what was called a heartbeat. It was, I think it was 16 milliseconds. It was just a pulse. And it told you that the other side of the link was up. Now that's one way to detect that you're going to do 10 megabits per second because the fast link pulse replaces that. So if you see the heartbeat pulse, you go, oh, that's a 10 megabit node. On the other hand, the fast link pulse also has a 10 megabit per second signal capability. So one of the messages in there says, look, I'm just going to do 10 megabits per second. Now here's the tricky part. We like auto negotiation. We want auto negotiation to be part of the game here. So in a perfect world, all your ports would be gig, all your ports would be able to auto negotiate, and all of them would be able to do full duplex. Okay. But if one side doesn't want to do it, then the fast link pulse or the auto negotiator side has to figure it out, right? So I can't say, oh, I'm going to do this. How about you? So what we do to figure out the speed is that you look at the transmission and you say, all right, based on what's happening in this transmission, I think it's either 10, 100, or 1000 base T. And then once you figure out the speed, you determine the duplex nature of the connection. And so if you're 10 or 100 megabits, it's automatically going to be half duplex. If it's gig, then the default will be full duplex. Anything that's outside of that, right, if you muck about with your settings, you're going to result in a duplex mismatch, something that doesn't make sense. So for example, you have a 10 megabit port that's doing full duplex. And so that would be an example of a duplex mismatch. Now, most hubs don't do fast link pulse, so they can create problems. And remember that if you're, first of all, we don't want hubs. Don't want hubs in your topology if you can avoid it because they create collisions or they're the location where collisions occur. And if they're causing problems with our negotiation, well, then we got to figure out what's going on. Let's take a quick look at the standard. You can go out there and download this, or if you are part of a library system or part of a university, you can get a copy of it usually through your library. So here is section 28 of the standard, physical layer link signaling for auto negotiation on twisted pair. And we'll just bop down a little bit here and we'll say, well, what are some things that we want to be able to do? There is an example of the pulses that might go on your network. So this might be a communication word here, and this is another parameter here. And then here is the diagram that I showed you. You can see that there's actually a lot of time frames that we're dealing with here. And timing is actually critical. And here's another example where we can actually see that there's a lot of measurements that go on. So it's not just that you're getting a burp of pulses, but there's some timing that's considered here. There are clock pulses and data pulses. But anyway, that is the fast link pulse that happens between nodes that want to auto-negotiate their parameters. Well, what about some manual configuration? Well, we can go ahead and take a look at this here in a second. So auto negotiation, right? We're going to, we want that on by default. In fact, almost all devices will have it on by default, and we like auto negotiation. But if you really have to turn it off, then all we really have to do is set the speed and set the duplex nature of it in a manual configuration. So let's take a look at that. So here we are in Packet Tracer. I have a couple of PCs and this multi-layer switch here. Now I chose the multi-layer switch because it has gig ports, but unfortunately none of the PCs do. So if we go ahead and connect this PC1 to port 1, what's happening right now, right? We can see the amber circle here. This means that the link is not up yet. It takes 30 seconds for links to come up on most switches. And the reason for that is that we're doing spanning tree discovery and we're doing all of this negotiation. And if we throw in there power over Ethernet, we're trying to figure out all of this stuff. So this is all what's happening right now. Now on the switch here, I'm going to cheat and use the CLI interface built into the node rather than connecting a console device. And I'm going to do a show interface. Well, we'll tab it all out here. Show interface, and I'll do status. Now, the only one that I'm connected to right now, and I was futzing around with this a little bit earlier, so this is the one that's right here. So we can see that this one is connected. that it's an auto as far as the duplex, and the speed is also auto. But even though it's a gig port, the CCNA, these are all 10100. So that's why we have this here. Okay, so we can see that this is set to auto by default. But what if I was to go into the interface? So I'm going to say int g1 slash 0 slash 1, right? That's this interface right here. And I'm going to say speed. Now, this is set to 10100. So let's go ahead and specify a speed. I'm going to say speed. Now, what are my options? Right there, it's pretty straightforward. So I'm going to say speed 100, and we'll just see what that does. And then I'll say, well, what else do we want to do with regard to this, this particular port? Now, a little spoiler alert, we're going to work with this one here in a little bit. But you can see on the simulation here that we don't have the duplex command, which is shown in the book. But let's go back and check our interfaces. And we can see that I have specified that I've got this speed here and that I'm no longer auto negotiating my speed, and that we've got our connected here. We'll do one other spoiler. We're going to do a show int. Now this is going into the particular interface here. And we can see that this is up, up. And so we've got the line protocol is up, meaning that it looks like we're going to be okay on the Ethernet side of things, and that we've got a link pulse up. Now also another spoiler, we have a whole bunch of counters down here that help us with our troubleshooting. So it's nice to see those more than one occasion. Okay, so let's go back and finish our discussion here. Now let's take a quick look at another switch so that we can actually see the command. We can see here that this particular model does have duplex associated with it. And so if I said duplex, and then I said, well, what are my options? I said half, whoops, right? And then I did a show run. Now this switch is not actually, oops, well, actually we'll do that. This switch is not connected, but we can see that in the config space, right, in the running config, I've got that duplex. But now if I do a show in status, now the duplex is the one that is not configured. Okay, so not all models will have the commands that you're looking for, but it's good to know about both the speed manipulation and the duplex manipulation you can do. So setting either one of these, setting the speed or the duplex, will take that part of the configuration out of auto negotiation. Now, when we're talking about MDI and MDIX, first of all, it's good to realize what MDI stands for. It's the medium dependent interface, meaning depends on what you're connected to, right? So this is your interface to the network. The other thing we want to remember is our cable types. So if I'm looking at something like this, right, this is a standard Ethernet patch cable, and it's terminated, right? You can see on the end there. Hopefully we can pick this up a little bit. Maybe even pick up some of the colors, right? Yeah. It's terminated with EIA 568B on both ends. And what that means is that this is a straight through cable, and it's very common to have these straight through cables in a wide variety of colors. But if I say I'm going to do 568B on one side and 568A on the other, right? Very commonly I wind up with crossover cables that are colored red. So we differentiate them because there's a world of difference between the two. The most important difference is that we cross the green and orange pairs in something like this. So what we're doing there is crossing transmit to receive. And if you remember way back when we were talking about Ethernet, when I connect two PCs directly to each other, I want to use a crossover cable. And the reason I want to use a crossover cable is because I want to send my transmission to your receive and my receive to your transmit. That's what crossover cables do. So normally, when you hook up PCs to a switch, we use straight through cables. So if we think about this for a sec, and I go, okay, I'm going to connect two PCs to the switch, and I'm going to use straight through cables. Well, wait a minute. When PCs talk to each other, we have to use crossover cables. And what's happening there is that the switch is automatically crossing our connections for us. So the right thing to do is use straight throughs wherever you're connecting to PCs. But what if you don't? What if you don't use the right cable? Or you're extending your topology to say, well, wait a minute, I am going to have more than one switch. I'm going to have a whole bunch of things. Then what we want is some ability on our devices to say, listen, dude, you used the wrong cable. So I'm going to figure it out for you. The auto-MDIX means I'm going to figure out what I'm supposed to do. So I'm going to hook up a couple of other things on the switch, and then we'll see how that works. So what I'm going to do is I'm just going to go ahead and hook up these PCs and let them do what they're supposed to do. Now you see that here in this case, I'm using straight through cables. That's exactly what you're supposed to do. And the switch itself is going to figure out the crosses for me. But what if I take a PC, like my PC4 over here, and instead I use a crossover cable? What am I thinking? Now I'm using a crossover cable here. And what the switch should do is figure out, listen, I know you were supposed to use a straight through, but I'm going to go ahead and figure out what the pinouts are supposed to do. That's the auto-MDIX feature that's on the switches. So there we go. It came up. Now if I take a look at my interfaces, if I spell it right, well, there's the speed change that I did earlier. We can see that even though I've used the wrong cable, right, all four of these nodes are connected. Like auto negotiation, we like auto-MDIX. Well, what happens if I turn it off? So I'm going to go int g1/0/4. There's what I'm going to mess with. So I'm going to say no MDIX. What are my options? Auto. And look what happened to the port immediately, right? It went down. So this is why we like auto-MDIX. People plug in the wrong cables all the time, or they plug in bad cables all the time. And so it's very handy that today's devices figure out a lot of this stuff for us. Now, sometimes it's very handy to add a description to something. You can add a description to a wide variety of things on the on a switch or on the commands that you do. And then we've got interface versus interface range. I'm going to show you an example of that here in a second. Of course, we've got the shutdown and then the negation of that. You can negate any command by putting no in front of it. And then we'll take a look at some interface status. Now, the interface status command I've been using through this entire video, but we'll take a little harder look at some of the things after we screw around with some stuff. So what I'm going to do is I'm going to say, just to get the ball rolling here, we'll take a look at our show interface status again, right? So this is a very handy, very quick way to see what's going on. And maybe what I'll do is I'll undo my auto-MDIX problem here with G0/4. So I'm going to say MDIX, oops, auto. And we can see now that it's coming up. So we'll take a look at our status again. And everybody's up, everybody's happy. Now, what if I wanted to shut down an interface? I could say, well, I'm going to go to int g1/0/1. And I want you to watch right here, right? And I'm going to say shut or shutdown. And this administratively brings down the port. The port is now disabled. You can't do anything on it, right? And if we take a look at its status now, we can see that this port is disabled. So that's its status where the other ones are connected. Now I could also do this. I could also say, well, I can add this description right here, and I could say description shutdown by Bruce. Okay. Now if I do a show run here, we can see what I just did right there. So that is the use of the description. Now, what if I wanted to shut down all of these ports? Well, I could go into each individual port and do that, but there's a much better way to do it. I'm going to say config T, and then I'm going to use the interface range command. So we see here, we take a look. I've got range right here. So I'm going to say range. Now what it wants is which group of ports are we talking about here? So I'm going to say F0/2, whoops, I forgot which device I was on, 0/2 to G1/0/4. Okay, take a look, my prompt changed, right? So you can see that. And I'm going to shut them all down. I'm going to shut them all down. And then I'm going to add a description that says, yep, shutdown. Okay, and then we'll do a show running config. And this was one of the questions in the do you know this already, right? So if we do a description after the interface range, it's for all of them. So when you do an interface range command, whatever you're doing, that is applied to all. So if I did the exact same thing, interface range, and now I said, I don't want them to be shut down anymore. There's no turn it on command. I would say no shutdown. And then I can change the description to up. Maybe we'll do up like that. Now the nice thing is that we don't have any errors and we have no collisions. So when you're doing troubleshooting, which is also addressed in the chapter, these are some of the counters that we're looking at. So the interface status, right? What I was doing throughout this entire video can show you a lot about what's happening with a particular port or a collection of ports, whether or not they're configured properly or whether or not they're administratively shut down, etc. And then with your statistics counters, they can help you troubleshoot whether or not you've got excessive traffic, excessive errors, or things like that. So those are the counters that we want to take a look at. So just to close up the idea of troubleshooting, right? Duplex mismatch, that can be a problem, but the goal, of course, is to always have auto negotiation on, to have auto-MDIX on, and so you don't usually run into these problems. Now, another variable that gets introduced here is that when you have power over Ethernet ports. So sometimes they can create additional, I'll just say configuration options for you. What a device is supposed to be doing is automatically configure how fast it's going to go, automatically figure out the duplex, automatically figure out the power needs. So for example, if you've got an access point or a phone that is powered by the switch, and then you're going to figure out spanning tree topology. So all of those things are happening before you can ever use it to transmit data. So a lot of negotiation that goes on, and your ability to take a look at those things can really help your troubleshooting. Layer 1 problems are pretty straightforward. If you have what we want when you do a show int status is you want up for a connected line. Now sometimes on serial links you wind up with a mismatch between the configuration parameters. That's the same thing that happens with a duplex mismatch, and those will give you connectivity problems as well. So take a look at your statistics, take a look at your status codes, and that should give you a lot of help troubleshooting your layer 1 and maybe even layer 2 problems. Here's our Chapter 8 look ahead. Chapter 8 is a big chapter. It is implementing Ethernet virtual local area networks, or VLANs, one of my personal favorite topics. It changes our network fundamentals because it creates barriers and mini switches. So we'll see how that works. So everything that you know about MAC learning, frame forwarding, flooding, all of those things are going to be modified based on the VLAN configuration. Even how network access works. So we're going to configure and build VLANs and maybe even connect bunches of VLANs together across switches via trunks. Very exciting. It'll be fun. Well, this has been Chapter 7, switch interface stuff. So we did speed, we did duplex, we did auto negotiation, MDIX and auto-MDIX, and then we figured out how to do manual configurations. And then we did some additional features like the description and the interface range command. Fabulous command. What a way to save on time and energy and your work. Use that interface range command. Use your status and statistics to help you with duplex mismatches and layer 1 connectivity problems. Okay, like and subscribe if you're looking forward to VLANs. I know I am. May those packets or frames always reach their destination no matter what you've done with your duplex or your speed. And hey, this is certification. You can do this.